Alrighty, good afternoon, everybody. How's everybody doing today?
Pretty good. Unfortunately, I'm sick, so.
Oh no.
Darn. Oh man. Yeah, I got ill about a week ago, so.
Oh, that's no good.
Hope you're feeling better. I hope so soon. Unfortunately, we all got it. My wife, my daughter.
Yeah, that's no fun. Yeah, spring's a hard time to stay healthy.
Well, the funny thing is I don't go anywhere, so it must have been at the store or something.
Oh, yeah. Yeah, it's hard to track these sometimes.
I scrubbed everything, desanitized everything so often that I kind of joked like no one could possibly get sick at our store, even with the flu.
Right.
Well, the funny thing is a month ago I had the stomach flu, so.
Oh, wow.
I don't know what it is. I'm just unlucky, I guess.
I had the
stomach
flu once, man. That sucks.
Yeah.
Yeah, it's no good.
Well, hopefully you feel better soon.
Thank you.
And we're going to talk about PA3 today, and hopefully that'll help. Because that's a fun assignment. Well, let's...
I went through,
yeah, go ahead.
304, ODP 304.
Mm-hmm.
And I would have had it the first try, and it really irritated myself because I returned, in the sum, I returned sum, and I put parentheses for some reason. And I don't know why. But, so I was basically returning the method instead of returning my variable sum.
Oh, interesting.
And I looked at it, and I was like, oh my god, it took me like 4 tries to run through it. I go, no, it's supposed to do everything that it's doing. And then I looked at it, and I saw the parentheses, and I'm like, oh my god.
Huh.
So
Interesting.
I did it, it worked good.
Well, that's good you got it to work. Alright, let's see. Oh, return some paren. Oh. Did that blow up your stack?
No, it just, I mean, I was able to compile it, and it worked perfectly fine. And then, I mean, it didn't work perfectly fine. I read through it, and I was like, this is going to work. I know it's going to work. So I just ran it. I did a main program on it. And then it said 2 out of 10. And so I went back in, and I looked at it, and I go, no, this is supposed to do everything that it's saying to do.
Right.
And then I missed the parentheses.
Yeah.
So,
interesting, because, yeah, that looks like it would recurse forever.
I would think so. That's why I'm pretty sure it got a 0, but...
Fun stuff.
I still have to modify a set for a panic button.
Ah. All right. Well,
it's. Assuming it just didn't see what it wanted to get back, so it just automatically said 0.
Yeah, but I would think they would blow up the stack, but it would take a while, and so maybe that's what happened actually. Actually,
maybe.
Let me see.
Because literally there was nothing to return; it just would have returned itself over and over and over again.
Yeah. So client. Yeah, it doesn't look like anything weird happened, so that's interesting. Okay. All right, and yeah, so regex. Yeah, so regexes are cool, but they can bite hard sometimes. And for this one, we just wanted letters in PA2, so stringing them together in a for loop is pretty safe as a way to do that. Regexes, I'll use them if I really need something that powerful. But I always feel kind of like, it's like when a genie grants you 3 wishes. If you don't phrase it just right, it's going to come back and say like, hey, this is what you asked for, this is what you get. And there's like, a 2-headed chicken in your string or something.
So, can I ask you a question?
Mm-hmm.
In speaking to a lot of the engineers I know, generally speaking, concatenating strings with plus signs like that is kind of expensive, or at least from what I've heard. And in testing this, I hit it with like a 90,000 word file, and got real slow. I don't know if that's just like it would naturally be that way anyway, but it seemed like the cost of allocating things was coming into play.
But I think regex is doing that plus a whole lot more.
Really?
Because it's got to make patterns and it's got to compile the patterns. And if nothing else, when it's trying to build up the result of the regex, it's probably concatenating characters one at a time. And so I think that would be at least as expensive.
Do you know if strings are vectorized in Java, maybe?
I do not know. But I ran this on War and Peace, which is 500,000 words, and you know it takes about 5 seconds to finish running.
I should have hit my program with a profiler. So
That would be interesting. See where the time's going.
Yeah, I did the Bible and War and Peace in about 10 seconds.
Oh, cool.
That was pretty cool.
Yeah, so the plus sign is I believe just a nod to say call the concatenate method in the string class. I don't know that for sure, but I'm assuming that's what it does. And I don't think that's a very expensive method. I mean, it builds a new string to add something to the end of it, but I would think that maybe it throws a buffer in there and leaves some space that's not used in case you want to concatenate more. I don't know.
So it's like vectorized. It's got an extra 8 spaces if you want to go ahead and concatenate something without making it a whole new allocation of memory.
I would guess there's at least some degree of that just because of like word alignments and such. I've never really tinkered around much inside the JVM. I don't know what they do for memory management and such, but I know there was definitely a lot of concern when Java first came out that it was like, you know, 1/10 performance because it was interpreted instead of compiled. And so there's been a lot of effort put into trying to make this thing as efficient as possible.
Meaning like it was like 1/10 the speed of like C or another.
Those were the numbers I heard when it was first coming out, and we were all like, you know, it's not C. But I don't know if that was just, you know, urban myth or what.
Well, now it's quite a bit faster than C, right? I mean,
That would be surprising.
I went in and did some reading on this exact subject not too long ago because you always think of Java and C# and some of those languages as compiled and not so much interpreted, but they are, and then Python would be an interpreted language. It actually mostly comes down to types, and because Java and C# are statically typed, the interpreter has to be way less complicated.
Okay.
So it's much faster in some ways.
I know I spent a while porting a really large Java project of mine to C++, and I got like, you know, a 5% speed up in the end, which really kind of shocked and disappointed me. So, I mean, it seemed pretty efficient, or maybe my C++ was really inefficient, but yeah, it was impressive.
C++ is a hassle sometimes.
Yeah. All right, well, let's look at ODP 304. So that posted yesterday. It's not due until Wednesday morning. And this is starting to play around with the idea of states in a programming context. And so the idea is to have, you know, say a method that you call, and it does different things each time that you call it based on things that have happened in the past, as opposed to a stateless function, which, you know, if you know what the inputs are, you know what the output is. And so this is the difference in 250, engineering 250, between combinational logic and sequential logic. Combinational, if you know the inputs, you know the outputs, no questions asked. Sequential, you know the inputs, but the outputs could be this or that or this other thing, depending on what happened in the past. So ODP 304 is an example of stateful behavior. So there's a temp readme 304. And so you're creating a class named add class. And there's really three pieces to this. So you construct it, and the constructor opens a scanner on standard in. So it creates a scanner, and you want to, save the scanner object as part of the class. And it has an internal running sum, just an integer that's initialized to 0. And then there's two methods that you can call after you've constructed the object. You can call the read method, and that should read one integer from standard in using the next int method of the scanner. So, scanner.nextInt will return an integer. And you take that integer, you add it to the running sum. And so if you call read, 3 times, each time it'll ask you for an integer, add the integer to a running sum. Anytime you call the sum method, it should return what the current running sum is. And so if I say something like, add class AC equals new add class. Alright, at this point, a scanner's been opened for reading from standard in, system.in. And now if I say add class.read, and let's say I type in, a 5, the class should have inside itself a running sum which is equal to 5 now. And if I say ac.read again, it will wait for me to type another number, and let's say I type in a 7. At this point, the internal running sum should be equal to 12. And if I say ac.sum, like I equals ac.sum, that should set I equal to 5 plus 7 is 12. And if I say ac.read, and then I said I equal to ac.sum, I would be equal to 5 plus 7 plus whatever number I typed here. So if I want to add a new number to my running sum, I just call read, and whatever gets typed in gets added to that sum. And anytime I want to know what the current sum is, I can just call ac.sum, and that'll return the current sum. And that's the whole behavior of the class. So it's a little peculiar, but nothing too bad. So create your add class.java program, compile it in the usual way, and test it with your own main program. So, maybe make a main program that does a few of these things and run it and make sure it works. If I call ac.sum before I've called read, it should just return a 0 because that internal running sum is initialized to 0. Once it's working, go ahead and assess it with this assess command. And I don't think I test this in this ODP, but one thing to keep in mind, if for example I said somewhere along here add class A2 equals new add class, right? I could do ac.read, I could do a2.read, and I could do I equals a2.sum. A2 and AC should be completely separate objects. They should be completely independent of each other. If when I did AC.read I put in a 5 and a 7, when I did A2.read I put in 1,000, A2 sum should be 1,000, AC sum should be 12. These should be completely independent methods from each other. The only weird thing is, I don't know if you can actually open a scanner on standard in more than once. That might be weird, so I'm not doing this. And that might misbehave. But with PA2, I should have been able to create 5 different indexers and processed each one with its own file, and each of those should work completely independently of the others. Which is one reason we never want to use the keyword static unless that's really what we mean. And so if I have a flag which says have I processed a file and I make that static, then it becomes a property of the class rather than the object. And it may be that once I open one file successfully, every time that I use the indexer class, it's going to think I opened a file successfully. So that's something to keep in mind, right? When you're creating classes, make sure that any instance of that class will function completely independently of any other existence. Internal running sum is just, like an integer called sum. Initialize it to 0 each time that you call read. Use nextInt to read a new number. Add it to that sum. And then when you say ac.sum, just return the value of that integer. But it's a running sum in the sense that you don't keep resetting it. You don't read two values, add them together, and then set it to 0 or something like that. Each time you say read, it adds to the sum that you had so far. Let's see, instant variables are part of the magic of classes. Yes, exactly. Static function bags are nice, though, also, like with the math class. Definitely. Welcome. All right, so any other questions on ODP 304? Is our AC just an integer? So, which AC? So, like in this example, AC is an add class. But that's just this example usage of the add class, and there's nothing about AC in the README actually. So add class is a class. It's going to contain an integer, which you can call whatever you like, and just make sure when you say read, it gets an integer using nextInt, adds that to whatever integer you're storing the sum in. And when you call sum, it returns the value of whatever integer you're storing the sum in. All right, other questions or further questions? The scanner should be constructed in the constructor. So the constructor sets an internal running sum to 0. The constructor should also open a scanner for reading from standard in. That's in the constructor itself. If you try to do that in the read method, you're going to end up trying to open the scanner multiple times, and that's going to fail. So in the read method, you use whatever you called the scanner, that thing .nextInt, to read the next integer. Right, but call has nextInt first to make sure it's available, and then call nextInt to get it. And nextInt returns an int, so you don't have to do any parsing and such, and you're not required to do any error checking. So I'm not going to run this where I type something different from an integer when I'm supposed to type an integer. No problem. Yeah, so if you don't need to do anything special in a constructor, you don't need to specify a constructor. There's always a default constructor. And in this case, you don't need to pass anything to the constructor, but you still want to have a constructor that opens the scanner and initializes the running sum. I mean, the alternative would be to have a flag that's initialized to false, and the first time you call read, check to see if that flag is clear, and if it is, open the scanner there. But then potentially, you're going to get an error message from your read method instead of your constructor, and that would be a little strange. So even though we're not passing a value to the constructor here, I still think you should write a constructor that opens the scanner.
Would I get any error for just doing that in the global class scope, though, as new scanner system thing?
Sorry, for doing that, what?
So I just put a message there, private scanner, new scanner system done in. Would I get any error for just putting that in the global class scope and not within the scope constructor?
So no, I think that would be perfectly fine, because that's not going to happen until you construct a scanner, a add class, and when you do that, yeah, I think that would work. Yeah, give it a shot, but I'm pretty sure that'll work.
Cool.
And then just initialize your sum to 0 wherever you declare it, just integer, running sum equals 0. All right, what else?
So, I was going to ask you one more quick question
Mm-hmm.
about exception handling
Yeah.
for PA2. So, it would have probably been a better idea to just put an exception around the scanner instantiation, so where I give it a file handle and it needs to handle a file not found exception.
Right.
But I chose to put most of the entire function inside of that try catch, inside of the try block. Is that a performance problem? Is it just a bad design, or is it bad practice?
So it's a little bit of a readability issue because you've got an extra level of nesting that just sort of confuses that. I don't know if it's a performance issue, but it's doing something that doesn't really need to be done. It would be like, putting a hello world inside a try catch block. Well, you don't expect, print line hello world to throw an exception. Why would you put it inside a try block, right? It doesn't really cause any problems, but from the point of view of, logicalness of code, it's a bit of a question mark. For larger projects where maybe your code's going to be maintained for 10 years by various people, right? It starts to become an issue of like, well, does this need to be in a try block? And if so, I'm going to add a statement here that could throw an exception. Is that going to conflict with the exception we're already catching, and so on and so forth? So it's this kind of simpler is better, but not too simple sort of mantra.
Well, in Java, you can set up methods to throw an exception, a special kind of exception. And if you're calling it and it throws an exception and it handles it a different way than what you're wanting, then it's kind of, not really what you want.
The other thing related to try catches, and I don't think I saw this in yours, but I saw it in some others, was, for example, asking for the nth instance of a word, right? Where was the fifth occurrence of the word? Well, you can find the linked list that has all of the occurrences, and you can say, you're asking for the fifth occurrence. Are there at least 5 elements in this linked list? And if there aren't, then you're asking for an illegal instance number, just return -1. But some people did that in a try catch. They said try to get the 5th element from the linked list, and if it throws an exception, then return -1. That works, but it's kind of a bit of a misuse of a try block, right? Because all you need is an if statement, and if you throw an exception, that's a kind of expensive operation. It's a difficult operation maintenance-wise, right? Because you're suddenly jumping from this statement down into your catch block, and there's no reason not to just do, if I is bigger than or equal to list.size, then return -1, or if I is less than 0, return -1. It's a little bit of kind of a lazy approach of, I don't know if this is going to be legal or not. Let's just try it, and if it's not legal, we'll jump into our catch block and do something. And so that was the other thing I tagged some people on. Sorry, say again?
Or if your hash map might be null.
Or if your hash map might be null, or if you or if you get a word and you try to add something to the end of the linked list, but the linked list is null, right? Well, just check to see if the linked list that came back was null, and if it is, then the word's not in the hash map. I don't.
That was the most frustrating thing for me, was trying to debug. Is it not reading the file, or was it like, because I kept getting null pointer exceptions, things like that. And as you know, on here we don't have like GDB or anything, or at least I don't know about it yet. So I had to try to figure out, why isn't it reading the file, and what's going on? And so I modified the file to where I was only reading the good one, and realized, okay, it's not that.
Okay.
Kind of work my way down, but
cool. Yeah, so there is there's this thing called JDB. It's the Java debugger. And I have not had much luck using JDB. I try it again a couple of times a year, and I got a little further the last time I tried. But I feel like it's a bare minimum interface to some debugging capabilities, but it's really meant to be wrapped in something more glorified. Because, you have to really kind of hand feed it everything you want it to do. There's basic things like, if you want to repeat the last command, you have to type in the last command. You can't just recall it or hit enter or things like that. But it does let you, single step your code. It lets you set breakpoints. It lets you look at objects and unwind the pieces of them and so on and so forth. But for most of what I've done in Java so far, good old print statements still seem to work really well for debugging. And Java code, function for function, tends to be smaller than C code for me. And so I don't necessarily have 1,000 lines of C and I don't know which one is misbehaving. I have 5 methods I'm calling. And I can put print statements after each of those and sort of figure out what's going on or where things are going awry. But JDB is something to look at. And you can Java C with a -G switch, which helps. And then I think just JDB in the name of the class. And it's got a minimal help interface built in. And the other thing that somehow I made it through 40 years of Linux without knowing this is rlwrap. This is a fantastic little tool. It basically runs a command, but it gives you command line recall opportunities. And that's really cool. So you can say rlwrap, whatever thing it is that you're running, and now you can up arrow to pull back previous commands. You can just hit enter to repeat the last command and so on. And that's pretty slick. And I learned that from looking at GDB. I think I was Googling why does JDB suck, and people were like, oh, this is terrible, but you can use rlwrap to repeat commands.
So JDB is meant to be the back end of a bigger application.
That's what it feels like to me. But it could just be I haven't figured out the magic to using it. But either possibly today, but probably Thursday, we're going to start talking about Eclipse. And PAs 4 and 5 will be doing an Eclipse. And Eclipse has some pretty nice debugging capabilities for debugging Java code. And lets you put in breakpoints and examine objects in a separate window and expand the pieces of them and so on and so forth. So we'll have some better debugging options there.
Can you feed JDB a file containing all your breakpoint setups, or?
I would guess not, but I don't know. I haven't tried. But just based on what I've seen or haven't seen in there, I would guess not. But usually what I do, I would just write those in a separate file and then just copy and paste them. And, you can copy by selecting, you can paste with a right click. And so it's almost as quick as saying, @ some initialization file. All right, good. Other questions at this point? I still want to talk a little bit more about PA2 and then go into PA3. So PA2, punchline, really great job, right? The grades were very high, reflecting the fact that the quality of PA2 was really good across the board. So most people got their PA2 to do everything that it was supposed to do. As usual, I posted feedback sometimes on things that did not cost points. And so make sure you read some of my feedback. The majority of places where people lost points were simply deviating from the specification of the assignment. So returning, 0 instead of -1. if you ask for the size of the hash and the hash hasn't been processed. Things like that. But the code looked really good. So people were wrapping, other methods with their, instance of or location of or things like that, which was exactly what we were after. And on this side of PA2, right? I mean, I would say people are extremely comfortable with this idea of objects and treating things as an object, and the object contains the code as well as the data and so on. I feel like people are in a place where they have a good handle on that, and that's fantastic, and that's going to be super important for the last two assignments of this quarter, PAs 4 and 5, where we're just going to be making some really kind of large applications and using a lot of pre-existing classes. So I didn't really see any concerns with that. A few people still not commenting, and so I started to take off points, in PA2. I'll take off more points in PA3. And that's just, make sure your name is in the top of each file. Make sure you have a description of each class. Make sure you describe each method, and you put comments on your code saying what's happening and why it's happening. What else was there in PA2? A few places where people changed, for example, what add reference was doing. So add reference does not say anything about uppercase, lowercase, punctuation, empty strings, stuff like that. Add reference says take a word, add it to this position. And that's the only thing add reference should do. Now your goal for PA2 was that, you should convert all words to uppercase. But add reference is not the right place to do that. Because now add reference is doing something different from what it's supposed to do. It's taking a word and it's converting it to uppercase and it's removing punctuation and it's making sure it's not empty and then it's adding it to a linked list. Well, that's a totally different function. And it didn't cause any problems in the way that you were using add reference, but the way somebody else might use add reference, that could cause critical differences. So you want to make sure that if you're told, what a function's behavior should be, that you stick to that, right, as precisely as possible. PA3, this is not going to be an issue because PA3, I'm giving you no requirements really on how you implement it. And so you're not going to have, a list of required functions with required signatures and so on and so forth. It's going to be up to you to come up with how you want to build the next program. Let's see, was there anything else in PA2? Let me see. Da-da-da. We talked about try-catch, keeping those as small as possible. Changing add reference. The only other thing is when you compile, if you get this notice about unchecked or unsafe operations, pay attention to that. And in most cases, this comes up because you say something like hash map, and you have to specify the type of key and the type of value. And a linked list, you have to specify the type of thing in there. And then you have to say new hash map. And here you have to say the type of thing that the key is and the type of thing that the value is, which is a linked list, and so you have to specify the type of thing that's stored in the linked list. And if you leave off these, or you leave off those, or you leave off the word integer, your code will still compile and it will probably still run correctly. But when you compile, you get this message saying, using unchecked or unsafe operations, recompile with -xlint :unchecked for details. Those types of messages, you have to make those go away. right? And if you compile with a -excellent flag on Java C, it'll tell you the line number or numbers where it's seeing a problem. And it's usually just going in and making sure if you had a generic that you specified the parameters that are required. In this case, that was the main issue.
Out of curiosity, with the linked list, if you were to leave out integer and then you add an integer to it, is it going to basically look at that and go, okay, we're going to make a linked list of integers?
I don't know what it does. I don't know if it defaults to integers or if it just goes ahead with the first thing you add and then hopes for the best. It would be an easy experiment to try, though. My guess would be it would put in an integer, and then if you put in something that couldn't be viewed as an integer, then it would complain. But it probably makes a linked list of objects, and an integer is an object, so maybe it lets you get away with it because of that. But I don't know.
It just compiles all the objects together.
Yeah. The JVM is one of these things I feel like I don't really want to know too much about how it works. It's like sausage legislation.
Just do it correctly, right, basically?
Yeah. And then there's Boolean algebra. All right. So yeah. So PA2, really good job. If you're unclear about how something worked or why something didn't work or so on, definitely let's talk about it. I'd like people to be very, very solid in their confidence of what they did on PA2, because like I say, this is really going to be the theme for PAs 4 and 5. And beyond Clark, right, if you do a course in Android development, you're just going to be doing Java. And you're not going to be writing a whole lot of Java code. You're going to be using a lot of classes and methods and putting them together, usually in pretty straightforward ways. And if you go into you know, anything else that's relatively modern, it's going to be object oriented, and it's much more about, you know, making peace with classes and this idea of encapsulation that that will be the biggest challenge. So let me know if you want to go over PA2, come by office hours or something. All right, should we go on to PA3?
I think so.
Let's do it. All right, so PA3, we're playing 20 questions. So, classic game where you have two people playing and the first person thinks of something. The second person's trying to guess what they're thinking of. So it's like high-low, but you're not just thinking of a number. Could be thinking of an animal, could be thinking of anything at all. And in the classic version, you're allowed to ask 20 yes-no questions. And the person has to answer honestly yes or no, and you try to figure out what they're thinking of. And 20 questions isn't a whole lot, right? I get more questions than that sometimes, you know, when I'm trying to order at Burgerville or something. But if you ask your questions well, you can do a lot of discrimination between one possibility and another with 20 questions. In fact, you can differentiate among a million different things with 20 questions. And so this is an assignment related to binary trees. And we're going to talk shortly about something called a decision tree and how we can use the decision tree to play this game of 20 questions. In the version you're doing for PA3, you're writing a program that will try to guess what you're thinking of. So it'll tell you, think of something, you'll think about it, and it'll start asking questions. And you'll say yes or no, and it'll try to figure out, you know, you were thinking of a purple pelican. And we're not restricting it to 20 questions, that's just the name of the game. But we'll play basically until, you know, it makes a guess, however many questions that takes. So let me start off with a demonstration. So there's sample code on the Linux machine. So let me go into a subdirectory. And there's a file under /temp called 20q.txt. That's the knowledge file. It's the database file that's used to play this game. And you can run a sample executable by saying java-classpath/temp pa3. So we'll just use that. And it'll say, "Shall we play a game? Tell me what you're thinking of." Okay, so who wants to try to stump this amazing program? I need a volunteer.
No, go ahead.
All right, so I want you to think of something. Don't tell us what it is.
Okay.
All right, you got something in mind, so let's go ahead and play this. Is it an animal?
No.
No. And the amazing machine has come to a conclusion and discovered that you are thinking of a laptop. Is that correct?
No.
No. Unbelievable, you stumped my program. All right, what were you thinking of?
A pipe.
A pipe. All right, so please tell me a question for which yes means a pipe and no means a laptop.
Can it handle water running through it?
Okay.
Oh.
All right, so now our knowledge base has grown. And so suppose we come back and we play with somebody and they're thinking of a pipe. So we'll say, is it an animal? No. Can it handle water running through it? Yes. And we'll say, okay, I've got it. Is it a pipe? And if it is, hey, you know, the amazing Java program read your brain. So we'll say yes. All right. So somebody think of something else.
Okay, I got something.
You got something. Okay, is it an animal?
Yes.
Yes. I'll bet it's a cat.
No.
No, okay. What were you thinking of?
Leopard, kind of same difference, but
A leopard. All right, so what's a question for which yes means leopard and no means a cat?
does it have spots?
Does it have spots? All right, so now the next time you play, is it an animal? Yes. Instead of saying it's a cat, it'll ask, does it have spots? And if you say yes, it'll say, hey, it's a leopard. But maybe you were thinking of a cow. So it'll say, what were you thinking of? A cow. So what's a question for which yes means cow? Does it say moo? All right, so now if you play, is it an animal? Yes. Does it have spots? Yes. Does it say moo? And if you say no, then it'll say, okay, it's a leopard. All right, so that's the basic gameplay. And you can... Yeah, go ahead.
It just keeps it, like, appending the last part of a tree kind of a thing?
Basically, yeah, so it's building a decision tree. So who wants to think of an animal against the large database? Because there's also a large database you can work with here. So let's just try that one. Who wants to think of an animal? Because the large base is just an animal.
I'll think of one.
Okay. So when you run PA3, you can specify the name of a database file. And there's this database file under /temp called 20qbig. So we'll go with /temp /20qbig.
Whole tree in a text file, not JSON or XML.
Nope, it's just plain text. And we're going to talk about how to read it in and write it back out. All right, so can the animal you're thinking of fly?
No.
Is it a very small animal?
Yes.
Does it live in trees?
Yeah, some of them do.
Okay. Does it eat gum leaves?
No.
I don't know what a gum leaf is. Is it an Australian animal?
Yeah, there are some in Australia, yeah.
Okay. Can it glide from tree to tree?
No. It can jump from tree to tree.
Okay. Is it green?
Some of them are.
Okay, we'll say yes. So not all of these are well defined. Is it born in the water?
Some of them are, yeah.
Okay. Does it have a white lip?
No.
Does it die when salt is put on it?
No.
Okay. That would be a poor slug. Is it a frog?
No.
No. Wow. What were you thinking of?
A spider.
A spider. Okay. So it won't let me update this database, but we could put in a question to differentiate a spider from a frog. That's interesting. You'd think a spider would be one that it could get.
Is it considered
Maybe because
an
it have
animal?
8 legs.
Well, it is an animal.
Yeah, it is an animal because it's also got it's got a lot of things in here that can be handled. It's got Papa Smurf and pink flamingos and Eevees and Pikachus and Papa Smurf is an animal. And the Mighty Duck. So this is a large database of 20,000 questions and answers. This, I believe, was crowdsourced. A student of mine who went to UW was talking to me about this assignment and offered me a copy of the database. So, that's interesting. A spider stumped it. All right. So this is a very large database. Here's the small database that you're going to start with. It's 6 lines, 3 nodes, basically. So is it an animal? If yes, it's a cat. If not, it's a laptop.
They're all prepositions, right? So it's just one or the other. So
Yeah.
one parent, two children.
Mm-hmm. Yeah, so it's always yes, no. And, sometimes these questions aren't well defined. Like, is it small? Well, what does that mean, right? But, the rule of the game is it's yes, no questions only. All right, so high level detail. So submission, right? You're going to make a class called PA3, which means it's going to be in a file called pa3.java. And all of your .java files have to go in a single tar file, pa3.tar. Canvas will rename that, don't worry about it. And just upload that tar file to Canvas by the deadline. Important note, when I build your executable, your class file, I want to be able to say javac pa3.java. So if you're doing anything fancy, if you're using packages, if you're making things in subdirectories and so on and so forth, you got to give me a make file. So I want to either be able to say javac pa3.java and have everything get compiled, or I want to be able to say make. And if you don't know what packages are or things like that, just do, all your .java files in one directory and you'll be fine. All right, high-level details. Not all of the information you need for this is in this document. Okay, this is a short 3-page document. I don't want to jam it up with everything we're going to be talking about for the next week and a half. So you got to take notes, you got to ask questions, you got to come to office hours and so on and so forth. You can't put this away, take it out a week from Thursday and expect to find everything in here you need to know to do the assignment. Okay. Not a big issue here. Yesterday's class I had 5 people in class, so most people missed this. This class has really good attendance, which is awesome. So you're here listening to this, you're fine. If you try to do this assignment without the information we give in class, you're not going to succeed, right? Most likely, because there are very important specifics. For example, the exact format of the file. I'm going to test your program against my own database files. And if you write a program that plays 20 questions perfectly, but with a different file format, it's not going to work when I test it on my test cases. So we've got to make sure we're all doing the same thing. All right, so high-level details. You're going to be implementing a binary tree. Okay, and so it's going to be a tree of nodes. We're going to go through sample code for a binary tree later. But this is not a binary search tree. It's what's called a decision tree. And so a decision tree, it's still binary. But we have a node and we have two children, which we can call yes and no. Yes is going to be on the left, no is going to be on the right. That's important. And basically, each node is a question. And you ask a question, and the person you're asking says yes or no, and that directs you to a different node. And that different node has some question, and you ask the question, and if they say no, that'll direct you to a different node. And if they say yes, that'll direct you to a different node. When you get to a leaf node, that's an answer node. If there's no children, then this is the end of the march through the tree, and you say, okay, I know what you're thinking of. You're thinking of a spider. So we're implementing these binary trees. And to play the game, you basically start at the root, which is guaranteed to be a question. You ask the question. You get a yes or no from the user, and you move left or right accordingly. And if that new node is also a question, you just repeat. You ask that question, get a yes or no, move to the left or the right. Get that next node. If that's a question, you just keep going until you get to an answer node, right? When you reach an answer, tell the person confidently, what they were thinking of. And if they're like, oh my gosh, you were right, then you can gloat and talk about, pathetic humans or whatever. But if your final answer is wrong, you want to improve the tree. And so let's start with our simple tree here. So, is it an animal? And if yes, it's a cat. If no, it's a laptop. Alright, so you see a question here, you ask it, the person says, yes, it's an animal. You come here, you say, were you thinking of a cat? And they say no. Alright, so what were you thinking of? You were thinking of a dog. And what's a question for which yes means a dog? Does it bark? So now what you want to do is you want to take this node, and instead of being an answer node, you want to change it to a question. And the question is, does it bark? And the yes node is the correct answer, which is a dog. And the no node is the old answer, which is a cat. And now you've got an improved tree. It's got more possibilities. And the next time you play is an animal. Yes. Does it bark? Yes, it's a dog. No, it's a cat. And you get down to cat and they say, no, I was thinking of a cow. What's a good question? Does it moo? So you change this to does it moo? And if yes, then it's a cow. If no, it's a cat. Or a cow who doesn't like to talk. And so the more you play the game, the better it gets, theoretically. But if you play the game and you give it bogus answers, then it gets worse, right? So. Alright, so if the answer is correct, no action is necessary. If the answer is wrong, ask for a new question to discriminate the correct answer from the incorrect one. Make a new node, put it in place. Alright, that's the basic gameplay. Any questions about that first before we start talking about the files? Saving the database on disk. All right. So database files. We start with this file 20q.txt. So the idea is we're going to store these trees in files. When you begin to play the game, we're going to read the file and build the tree. Every time that you improve the tree, we're going to rewrite the file. we're always going to make these improvements and changes to the tree in memory, but after we've modified the tree, we'll just write it back into the file. So that if you exit the game and you come back later and you run with the same file, it's got the enhanced tree on it. Alright, so let's start with a simpler direction, which is writing the tree to a file.
Sorry, I stepped away for a second. We're going to be using basically the traversal methods from 224, right? Or not
222.
There you go.
Yeah.
Okay.
Alright, so here's our simple starting tree. Is it an animal? Yes, it's a cat. No, it's a laptop. Okay, to write this into a file, we're going to use a pre-order traversal, node left right. This is super duper critical. So first we're going to write the value of this node, and then we're going to write the value of this node, and then we're going to write the value of that node. To write a node, we're going to use two lines in the file. The first line is either a Q colon or an A colon, and then the second line is the actual text of the question or answer. So this Q colon followed by is it an animal, that corresponds to one node, the root node of the tree. The A colon followed by cat, that's the left child or the yes child, and the A colon laptop, that's the right child. So let's play this. And this plays against 20q.txt by default. Okay, so is it an animal? Let's say yes. Is it a cat? No. What were you thinking of? I was thinking of a dog. Does it bark? Alright, so what have we done? We've modified our tree. So instead of having a cat here on the yes node, we say, does it bark? And if yes, it's a dog. If no, it's a cat. So what happens when we traverse this tree in node left right order? First thing we're going to do is print out the root node. So we're going to see Q colon, is it an animal? And then we're going to traverse the left subtree in this order. And then we're going to traverse the right subtree in this order. So to traverse the left subtree, node left right, first we print out the root node, which is a question. So the question is, does it bark? And then we traverse the left subtree in node left right order. So we print out the root node, which is an answer node saying it's a dog. And we know it's an answer because there's no children. So there's nothing to print on the left or the right. So we've done the node, the left, and now we're going to do the right, and that's going to be an answer node, which says cat. And now we've done the node of the original tree, the left subchild of the root, and now we're going to do the right subchild, which is another answer node, which says laptop. So the NLR traversal of this tree would be question animal, question bark, answer dog, answer cat, answer laptop. And if we look at 20q.txt, right? Question animal, question bark, answer dog, answer cat, answer laptop.
So, if I'm reading this correctly, the answers are always the leaf nodes, right?
Correct.
Okay.
And that's how you can tell you're at an answer node, is because there's no children.
Cool.
So once we go through some sample tree code and we look at some ways to traverse a tree, writing your tree out to a file is just a matter of opening a print writer, which we talked about last time. Open a print writer to, write into whatever the database file is, 20q.txt for example. And then as you're doing your traversal, when you want to print out your root node's value, just do, print writer.println and print that out. Prefix it with a Q colon or an A colon based on whether this is a leaf node. All right, so this talks about this. So after the initial decision tree should be read from a file. After being modified, rewrite it to the same file. Traverse in pre-order node left right to simplify the reading writing of this file. There's the initial database, and you can assume that if you're playing your game for the first time, that 20q.txt has at least these 6 lines in it. So we don't have to deal with the case where the tree is empty. That just makes life a little simpler. All right, we need to talk about how to ingest from the file, and we need to talk about how to implement binary trees in Java. But let me finish the high-level pass. So recommendations: do this in pieces, right? Reading the decision tree from a file is tricky. It's recursive, and it's got to be done just exactly the right way. Otherwise, you end up with something different from what you think your tree looks like. So my suggestion is make life easier on yourself. Start off by just building a tree using some assignment statements. Once we have our tree class and node classes described, right, we can make a node for dog, a node for cat, a node for bark. We can set bark.yes equal to this, bark.no equal to that. Make a node for this, set animal yes equal to that, animal no equal to that. Now you got a tree, right? And you don't have to worry about ingesting from a file. This lets you get the basic core of the program working, the part about playing a game, asking the questions, moving through the tree in the right way, knowing when you've got an answer node, and so on. And it also lets you modify the tree in memory, right? And you can do all of that without writing it back out to file or reading it back in. Programming challenge over break to serialize, deserialize trees. Yeah, it can be a bit tricky. That's a cool challenge, though. What would the default question be? Does it have a platonic form? Is it composed of some combination of elements? Maybe does it exist? Or does it have an essence? Or does it exist independent of an observer? I don't know. That would be a fun analysis. Or you could do like the existentialist 20 questions. Which would be really freaky. I am. No. All right. You can use the built-ins that we've been using from Java. You can use scanners, print writers, strings, characters, file, right? But don't use, any pre-existing packages for doing trees. Don't use, the 20 questions class that you download from somewhere or things like that. You got to write most of this yourself, including all of the tree handling, the parsing of the input file, and so on and so forth. One more time, stay away from the IDEs, right? Do this on the command line. We'll get to Eclipse for PA4 and 5, and we won't look back after that. But stick to the command line for PA3. It will be good practice. It'll help you on exams. We talked about pa3.java. You normally run it by just saying java pa3, and it will read from 20q.txt in the current directory. If you say java pa3 file name, it'll read from this file instead. So check the length of your args array. If it's got a length of 1, then use args bracket 0 as the file name. Otherwise, use 20q.txt. Make sure that the way you code this, the user is thinking of an item and the game is trying to guess it. Don't code it the other way by mistake. You can also assume that the database file, if it exists, is not corrupt. So I won't give you a file with garbage in it or that's missing a line or something like that. So you can assume if I run this with, database.txt, that is a correctly written node left right traversal of a decision tree. So you don't have to worry about corrupt files. Sample databases over here. If you want to play with them, copy them into your directory because these are read-only. And sample executable is in /temp pa3.class. Grading rubric, very straightforward. If I can compile, you get 20 points. So you can turn in hello world and get 20 points. If it asks questions and makes a guess at some point, that's another 10 points. If it actually reads a database file, builds a tree, and plays the game by traveling from the root down, that's another 30 points. If I can specify a different database on the command line, that's another 10 points. That's an easy 10 points. Let's just check args.length. If it's equal to 1, use args bracket 0. If it updates the database file, if the guess is wrong, that's 15 points. This is a little tricky, but not too bad. And then for this one, style points are all or nothing. So to get your 15 points for style, you need to have your full name, date, description of the project, and the beginning of pa3.java. Consistent indenting, placement of braces, and so on. All your code has to be commented. Every method has to have a block of comments in the beginning. And I'm going to up the bar a little on the quality of the comments here, right? So for process file, I got comments like process the file. And I let that go, right? But I'm going to want comments on par with if somebody has no idea what this method does. Is there enough in your comment block to give them the basic idea of what this is doing? So, tell me what the purpose of it is, what the arguments are to it, what the return value is, exceptional conditions that could happen, and so on and so forth. And then every class, I want a block of comments in the beginning in your own words, telling me about the class, and including your name and your date. Right? Now every class should go in its own file, so this means every file has your name, date in the beginning of it, and a description of the class contained in that file. And if you're writing a tree class, don't just say tree class. This class implements a binary decision tree. Yes, children are on the left, no children are on the right. This includes methods for adding nodes to the tree, traversing, and doing blah blah blah, right? So bits are free, use them, right? Imagine that this is being read by somebody who does not know what your methods are supposed to be doing, right? Put enough in your comment blocks to tell them that so that they don't have to go in and look at your code and reverse engineer it to know what this method is, right? So all of these things get you 15 points, right? PA2, I gave you chunks of 3 points for each of these categories. You need all of these to get any points at all. That's pretty much it for the assignment prompt. Let's see, caveats to a recursive instance method, and that challenges I just mentioned that your static factory method instead of instance method. I don't believe you need to do any recursion here except for ingesting the tree and writing the tree out to the file. But playing the game is definitely not recursive.
That's what I meant. Like, should I kind of want to try instantiating via like an instance method, but I don't know if that's possible. When you load in the whole file and it has to parse the whole tree.
So my first comment would be make sure you don't do something that's going to blow up on a modest size file. If I want to read in 1,000,000 lines of decision tree, that should not cause problems for your ingest. And if you go a little too wild with the recursion, it could. Even though we're going to recursively ingest the tree, it's going to be recursing based on the height of the tree. So 1,000,000 nodes, 20 levels of recursion, not a problem. But be a little cautious if you feel like you're starting to do a lot of recursion. Ask yourself if it's getting really expensive in terms of resources.
Well, I wouldn't be recursing quite a whole lot. I would just, when I load in the tree, is there any penalty for using like an instant, or is there anything wrong with doing a recursive instance method versus like a static class method to instantiate the whole tree for you and a static function to return it?
Not that I can think of, but I might not understand exactly what you have in mind.
I'm wondering whether I should do this via a factory method to build the whole tree from some class that's going to store the whole tree, or should I make an instance method on that class to ingest the file and build the whole tree itself?
I'm picturing it with an instance method.
Okay.
But if you want to explore a factory, you could try that. And you can ping me along the way and say, hey, does this look okay? Just don't do it at the last minute.
Gotcha.
And in general on this assignment, I'm trying to leave people a fair amount of leeway in how they implement it. I'm going to give you some specific algorithms and recommend some specific methods that work well with those algorithms. But I'm going to leave a fair amount of flexibility in how you decide to actually go ahead and implement this. And I'm very much concerned with, how the game plays out, how it reads and writes the file and updates the file accordingly. And not as worried about, did you do this exactly the way that I was thinking of? Because I'm not specifying in here, a lot of rigid requirements. So you got some wiggle room. All right, well, let's do a 5-minute break, and let's come back at just over 5 minutes, and we'll look at the business of moving between the tree and memory and the file on disk, and then we'll start talking about implementing trees in Java. So I'll see you back here in about 5 minutes. Me too.
Oh, we could do like an hour nap.
You got it.
Oh, cool. Or a little under, but that's okay.
You would?
I said it'll be a little under an hour, but that's okay.
We'll put on a snack.
Right.
Unlock the door.
Yes. Hey, check this out. I found another one. This is from when my dad was 5, so I'm going to give this one to him.
Whoa.
Yeah.
Wow.
So apparently you can just find these, man.
Yeah.
I don't find. Did your dad have these?
Yeah.
Yeah. That's right. We wrote down his thingy. I need to look that up again.
Yeah, check it out.
The guy that's sold this, he just has like. Where's the guy? He has like 8,000 of different ones.
Yeah.
So if we could just look through, somehow search through. Where's his other ones?
Try K2HJR.
How do I search it? It's so weird.
I never tried Googling.
So what was it?
KA2
2
HJR.
HJR.
I mean, FCC has it.
Okay, so that was, I was like, oh, because it was like that, you know.
I don't know how old it is.
KA2HJR.
2006. It's not that old.
Do people reuse?
Mm-mm.
Use? Okay.
I don't believe so.
I could save a search for that though. And so if it comes up, then
I've got some of his cards somewhere.
that's cool.
There's a whole page on it from the FCC.
Oh.
January 31st, 2006. Oh, they canceled it in 2018.
So that would have been an Endicott?
Yeah.
Some parts. How cool. Ah, it's neat.
Still haven't read the sad news of co-joined twins. It's been on like the headlines for days.
More like years.
Ancient crop circles finally explained. All right, welcome back. So, let's talk about reading the tree from a file. And so I'm going to refer to this as ingesting the tree from a file. So pulling it in. And let me make a general comment here. We really want to do all of our tree manipulation in memory. So in the very beginning of the game, you're going to read from a file and build a tree in memory. To play the game, you're going to use that tree in memory. If you get the final answer wrong and you're going to make adjustments, you're going to adjust that tree in memory, right? All of this is going to be done on your binary tree structure in memory. But after you've adjusted that tree, you're going to write it out into the file. What you do not want to do is try to modify the file based on an incorrect answer, because it's almost impossible for us to understand the contents of a file corresponding to a tree. Sometimes, if you're going to add a new node in response to a question, sometimes it'll end up getting appended to the bottom of the file, but sometimes it will end up in the middle of the file, right? And it may end up, right after some previous question, or it might end up somewhere else. We don't want to try to understand the mechanics of how this tree gets represented in the file. So we're going to do all of the adjustments to the tree itself in memory, and then we're just going to do a node left-right traversal, dump it back into the file when we're done. So the flip side of that is when we're beginning to play the game, first thing we're going to do, we're going to read the whole file and build a tree. We're not going to play the game from the file itself, because that's really hard to do. If you read the question and the answer is no, it could be 2 lines down, it could be 2,000 lines down, right? So game playing, updating the tree, always done in memory. In the very beginning, we read from the file into a tree. When we've made an update, we write from the tree back into the file. So writing into the file, that's just the node left-right traversal. So the piece that I want to talk about now is, given a file, how do we build the tree? And the file can look very, very sort of strange. So here's a question and a question and a question and a question and a question. A whole bunch of questions here. And then a few answers. And then one question and 2 more answers. And then 2 questions. And 1, 2, 3, 4, 5 answers. And then a question and an answer, and so on. Right? So the goal is, given all of this information, how do we turn this into a tree? And it turns out there's a really, really simple way to do this if we use recursion. So let me pseudocode an algorithm. I'm going to call it ingest. And ingest should return something like a binary tree. It should read from a scanner. So before we ever call ingest, we're going to open a scanner for the database file. And we're going to pass that scanner to this ingest method. And it's just going to start reading from wherever it happens to be in that file. Alright, and when we read a line from the file, we're actually going to read 2 lines. The first line is going to be a Q colon or an A colon. The second line is going to be a set of text. So I'm going to think of this for the sake of pseudocode as, just reading the next line from the file, which is going to be a question or an answer. Right? But when you actually implement this, you have to read 2 lines, look at the first one, see if it's a Q or an A, and so on. But pseudocode, right? So how do we ingest from a file? So read a line, make a node. So let me make a sample file here. So question, is it an animal? Question, does it bark? Answer, dog. Answer, cat. Question, is it hard? Answer, rock. Answer, pillow. Alright, so here's a random sample database file we might want to turn into a tree. Alright, here's our ingest algorithm. First we're going to read the first question or answer, and we're going to make a node. And if it's an answer, then we set the yes and the no children to null, and we just return that node. So that's easy. If you read the next line and it's just an answer, make a node containing that answer, set the yes and no children to null, and just return, and you're done. Alright, otherwise, call ingest, take the tree that comes back, set your yes child to that. Call ingest again, take the tree that comes back, set your no child equal to that, and then return the node. And that's it. This is sort of undoing the process of a node left-right traversal. First we read in the root node, then we read in the yes tree, then we read in the no tree. The edge case being if the node that we read in is an answer node, there is no yes or no subtree, so we don't do the yes and no ingests. We just return right away. Alright, so let's see what this does. We open our scanner, so our scanner is pointing right here. Okay, we're ready to read this first question, which is animal. So we're going to read this line which says animal. So we'll read those off, and now we're sitting right here. We're going to make a node out of this, so we'll make a node which says, is it an animal? If that was an answer, we'd be done, but we're not. So we're going to call ingest 2 more times. The first time is going to set the yes child. The second time we'll set the no child. So we're going to call ingest. Okay, well what happens when we call ingest with our scanner pointing right here? We're going to read a line. And we're going to make a node out of that. So we're going to have a node saying, does it bark? And it's not an answer, so we're going to call ingest again and set the yes child equal to what we got back from ingest. Alright, so we read the question, we're sitting right here. We're going to call ingest, it's going to read this answer node dog. It's going to make it into a node. It's going to say, hey, that's an answer, set the children to no and return. So it returns this node, and that becomes the yes child. And now we call ingest a second time, and we read an answer node which says we're a cat. And so that creates a node containing cat. It has no children, so we return that node. And the previous call says no should be equal to the result of ingest. That sets this up. And now we return this node, which was, this bark up here. Well, our original call to ingest, right, we read a line, we saw that it was not an answer, so we said yes equals ingest. We just finished this statement in our original call, and we set the yes node of this equal to bark. Now we're going to call ingest again, and the process will repeat. We'll read a question node, so this will say, is it hard? And it's not an answer, so we'll call ingest again, and this will read an answer node, which says rock. And since it's an answer, it'll have no children, we'll return it, and our call says set yes equal to the result of ingest, so the yes node of hard becomes rock. And then we'll call ingest one more time, and this will consume pillow. It's an answer node, so we set the children to null and we return it. And this last call to ingest says set the no child to the result of ingest, so this becomes the no child. And now we return the node, so we return this hard node. And this was our second and last call to our original run through ingest, which said set the no child equal to ingest, so the no child comes over here. Our main call to ingest returns this node. We're done, we've got a tree, and we've hit exactly the last line of the file. And now we have a decision tree. Is it an animal? No. Is it hard? Yes, it's a rock. No, it's a pillow. So this is recursive. And if you get it set up right, it's pretty easy. But it's tricky to set up just right. But basically, read your first two lines from the scanner. And this first line will tell you if you're reading a question or an answer. If you're reading an answer, just set your string equal to, the second line you read. Set the yes and no children to null, return that node. But if the thing you're reading is a question, you need to make two recursive calls to ingest. The first call returns a tree, set your yes node to that tree, call ingest again, set the no node to that tree, and then return your original node. I wouldn't recommend making this the first thing you work on. You could totally work on this part of it first, but I think it's easier to work up to a correct implementation if you start by playing the game. Because once you have a tree in memory, playing the game is just a loop, right? Set temp equal to this node. While temp is not an answer, ask the question, get a yes or a no, set temp equal to temp.yes or temp.no, go back to the top of the loop. If this is not an answer, it will ask the question, get a yes or a no, set temp equal to, say, temp.no. This is not an answer, it'll ask the question, wait for a yes or no, set temp equal to, say, temp.yes. Now temp is here, but now temp is an answer, and so say, you're thinking of, and print out the text from that node. All right, questions up to there? So some ideas on how to proceed based on what we've said so far. Build a tree by hand. And in 222, when we started working with trees, one of the first things we did was build a tree by hand, right? We said root equal to malloc. We said root left equal to malloc, root right equal to malloc. We said root data equal to 10. We said root left data equal to 5, root right data equal to 20. and we made a little 3-node tree, right? And if you work carefully, draw yourself some pictures so you know what you're after. You can build a decent sized decision tree, with a half dozen nodes or something in it, and then you can use that to do your development, right? And we'll look at some class structures for trees and nodes in a minute. But if you put this together by hand, you can skip the reading from the file. You can skip the writing to a file. Don't worry about correcting the tree if the answer is wrong. Just build a tree piece by piece and try to play the game. And playing the game, like I say, it's a while loop. Start off with temp equal to the root, and while temp is not an answer, ask the question, get the answer, move left or right. So yeah, this has a lot of pieces to it. But if you start with one piece like building a tree, and then add one more piece like playing the game, you'll understand the pieces better this way. And the more you understand the pieces, the easier it is to add more pieces to it. As opposed to I'm just going to write the whole thing, and you got to figure out what all these different aspects of it are. So definitely starting smaller will help. So build a tree by hand, play the game. No files, no correction. This also gets you through a lot of the kind of mechanical parts of printing out the questions or answers, knowing if you're at a question or an answer, getting an input from the user, figuring out if they said yes or no, things like that. And once you've got those coded, then you can just keep using them. You don't have to keep worrying about them. You're going to need to have a scanner from standard in to read the yes/no answers. You're going to need to have a scanner from a file eventually, so you're going to have at least 2 scanners in here. But for starters, don't worry about files. Build a tree by hand in memory. And play the game. And then maybe write the tree to the file. Because that's relatively straightforward. You got to use print writers, which we talked about Thursday. You got to use print writers to open a file and then do the node left-right traversal, write the data out to the file. And then you can eyeball the file and see if it looks reasonable, right? And then maybe at that point, maybe ingest a tree from a file. And that's tricky-ish, just because it's recursive. But that's one of these that if you get it right, it will make sense and it will be pretty straightforward. And then maybe correct tree if your answer was wrong. And this is not too bad, but it takes a little bit of housekeeping. So correcting the tree. So let's say you're playing the game, and let's say you're thinking of a cow. So is it an animal? Yes. Does it bark? No. Is it a dog? No. What were you thinking of? I was thinking of a cow. Okay, so I need to do a few things. I need to take this node, which is an answer right now. I need to change it to a question. And if I have access to this node, I might be able to modify it directly. Or I might need to remember that I went to the yes side of this node, create an entirely new node containing a question, does it say moo, and change this thing's yes child to be that new node. But you may be able to just change the value in here to say, does it say moo? And then on your yes side, put the correct answer, the thing the person was thinking of. On the no side, put the incorrect answer, which was dog. So this is certainly easier than deleting from a binary search tree. right? But it requires a little bit of the same skills in terms of, you know, knowing that I'm right here and I want to replace this node with this little 3-node tree, and being able to build this tree containing, you know, the question the user gave you, what they said they were thinking of, what you guessed they were thinking of incorrectly, and then putting that right here as a child of the previous question. And so maybe do that one last. But, you know, there's different ways to do this, but I definitely think these are good ones to start with. And then where you go from that, you know, can kind of be like what you feel like doing. But once you get through this, you're done, right? That's the whole thing. Play the game, read the file from a tree, play the game, correct the tree if the guess was incorrect, and write it back to a file. Alright, let's look at classes and such. So your main class is going to be pa3.java, pa3.class. And that's just, you know, a wrapper for your public static void main, which is going to play the game, right? So process the command line argument, open the database file, build a tree from it, go through the process of playing the game, update the tree at the end, keep going, and so on and so forth. So you're also going to need a class for a binary decision tree. And so this gets a little different from C. The reason being, okay, so what's a binary tree? It's a collection of nodes that are connected to each other, right? When we did this with lists, we had sentinel nodes. So that if you didn't have anything in your list, you still had a sentinel node that you could use as a handle. We don't have sentinels in trees. Sentinels would make the recursion very difficult. So an empty tree does not have a root. But we want to construct a tree in our main program, like, you know, tree t equals new tree, right? This is not going to be null. This is going to be something. But if we don't have any data in the tree, there should not be any nodes associated with the tree. So this tree object is a separate thing from the nodes in the tree itself. So in addition to wanting a tree class, we're going to want a node class. And in our tree class, we're going to want a node called the root. And that will be initialized to null, meaning it's an empty tree. But in our main program, when we do this, we have this object t, which is an empty tree, but it's not null itself. So to a large degree, the tree class is really just a wrapper around the nodes themselves. And so this is going to look a little weird maybe, but we're basically going to have a node class that has most of the methods that we're going to use. Methods for adding nodes, for moving down from node to node, and so on and so forth. The tree class is going to have methods that are just wrappers around those node classes. So our node class is going to look something like this. There's going to be a string, which is, you know, some text message. Is it a dog? Does it bark? Or, you know, cat, rock, laptop. So a string, which is a text. You may want a Boolean flag to tell you whether or not this is a question or an answer. So maybe you have a Boolean variable called question. If this is true, then this text is a question. If it's false, this text is an answer. And then you want children, which will also be nodes. So a node called yes and a node called no. And those are the main fields in your node. So the actual text of the question or answer, something to tell you whether that is a question or an answer, and then a yes child and a no child. And
Wouldn't
yeah, go ahead.
wouldn't if yes and no are both null, wouldn't that also mean it's an answer because it has to be a leaf node?
That means it's an answer. So do we really need the question Boolean? Probably not. So you've got some options here, right? One option is every time you want to know, is this a question or an answer, check to see if your yes and no are both null. And if they are, you've got an answer. If they're not null, you've got a question. Another possibility would be you could make a method. So a Boolean is question, which returns true if yes and no are non-null, and false if they are null. And now if you have a node n and you want to know if it's a question, you could say n dot is question. And you'd be calling a method which would do this. It would say, let's see if the children are null or not. And it's totally up to you.
And if you think about it, if 20 questions is potentially 1,000,000 pieces of data, you might save 1,000,000 bytes that way.
This is true.
That Boolean.
Yeah.
After we started talking about tries, I always like to think of how to make a tree super memory efficient.
Oh, nice.
Or the try, the 26 node one.
Yeah, yeah. Yeah, and this to me feels very object oriented. So there's kind of a rule of thumb in database design about redundancy, and redundancy is usually bad. You don't want a piece of information stored more than once because there's the potential for things to get out of sync. This is not talking about redundancy for efficiency of error recovery and so on and so forth. But in some sense, having a Boolean flag here replicates information that's available by looking at whether these are null or not. And if I potentially found myself in a situation where these were null, and this claimed that there was a question instead of an answer, right? That's an impossible situation. So this feels more like kind of the natural way to do this from an object-oriented mindset. Is, hey, look at the fields that are already available and tell me, information about the state of this node. But whatever makes sense to you is fine. So you can think about that and make some decisions. And particularly, in a programming class, it's a really good place to change your mind. Now, not so much that you miss the deadline, but you might do this and keep updating this flag and checking this flag and so on and so forth, and at some point say, you know what? That's silly. I should just make this thing a method, right? Well, you can do that. You can go back and change it. Some of the larger projects I worked on, especially earlier in my Java lifetime, I've gone back and rewritten 2 or 3 or more times, and some of them I look at now and it's like I would just totally start from scratch and rebuild this because it is so different from what I think it should be at this point. That's all like good experience to learn through doing something one way that, hey, there's a better way to do this. That's a very positive experience. So don't shy away from those.
I hadn't really considered it that way because usually I'm the kind of guy that likes to have a private set public read, but instead using a method I save quite a lot of space that way, and it's more natural than well, if this node is null and this node is null, you could just have a wrapper around that with a function.
Mm-hmm. Yeah, cool. The only thing I would say is don't try to do something like, if the last character of this is a question mark, it's a question. Otherwise, it's an answer. because now you're putting requirements on the database file that might not apply. So don't try to do that. But
It'd be really funny if somebody did, though.
well, I mean, it's not an unreasonable approach, and if I was the only person creating the database files, that would be fine, and I would make sure there was always a question mark at the end. But then sometimes, the more you play, the more question marks you get on your questions. All right, so something like this for a node structure, and your tree class is really just, mainly contains a node called root that initializes to null. And if we wanted to do, let's say just a plain old in order traversal, so let's just make a print method. So, public void print. So this is going to do an in order traversal, so not for PA3, but just a plain old in order traversal of a tree, left and then node and then right. And we're putting this in the tree class because, at some point your main program might want to do something like t.print. So how do we do left node right traversal? Well, we would print the left subtree, and then we'd print the root node's data, and then we'd print the right subtree. But here's the trick: since the root of the tree is a node, the left subtree, well, here I'm using yes, no, but imagine the left subtree. The left subtree is also a node. I can't call print on the left subtree because print is in the tree class, not the node class. So I'm going to need a print method in the node class as well as the tree class. And so here's what I would do. I would do something like this. If root equals null, just return. So if my tree is empty, nothing to print. Otherwise, I'm going to say root.print. And so my tree's print method is really just calling the print method on the root node. All right, so let's do an example with just a plain old binary search tree. So we'll forget about PA3 for a moment. And so let's have, an integer field called data, a node field called left, and a node field called right. And let's look at a print method. So we're going to do a left node right traversal of what? Of the tree whose root node is this node that we're sitting in. So if I call root.print, I should be traversing the tree whose root is this node. If I call haha.print, I should be printing the tree whose root is the node called haha. Right? So this is a method in the node class. And what do I want to do? I basically want to do left.print. And then I want to do print line the root node's data, and then I want to do right.print. Right, we're missing some details, but the high level goal is let's recursively print the left subtree of the tree rooted at this node. Well, that's this node called left. So left is a node, let's call that node's print method. And then let's print the root node's data. Well, that's in this field called data, so we'll just, do a system out print line. and then let's print the right subtree using left node right. Well, that's just calling the print method on the right subtree. And so this looks a lot like tree traversal from 222 in C. But we gotta take care of our edge cases. And that looks a little different from C. So we know that our node exists if we're running print, because the only way we run this is by saying the name of some node dot print, right? Root dot print or haha dot print or something. So we know that this node exists. But its left child could be null, its right child could be null. So we've got to do something like, you know, if left is not equal to null, then let's call the left child's print method. We know data exists, so we can always print line data, and then here we could say if right is not equal to null, call the right child's print method. And that would give you a perfectly fine in-order traversal.
So we're going to be reading in a pre-order traversal and writing in a post-order traversal?
No, this is not a PA3 thing. This is just an example.
Oh, okay.
Yeah.
Got it, sorry.
That's okay. So yeah, when we write the decision tree back to a file, it's also going to be pre-order node left right. Alright, so in my main program I could construct a tree by saying tree t equals new tree, and I could add data to it by saying, for example, t.add 5, t.add 10, t.add 1, and then I could say t.print, and it would print out, you know, 1, 5, 10. So t.print, print is a method in the tree class, because t is a tree, and all it really does is call print on the root node. And same kind of thing is going to happen with t.add. This has to be a method in the tree class because, you know, t is an object of type tree. So I want to say tree.add, but what that really should do is just call root.add with, you know, the number that I want to add. But we need to handle the edge case where root does not exist. So if we call t.add 5 and inside this tree object the root is equal to null, what do? Create a node containing a 5, set root equal to that node, and return. Now if we call t.add 10, we're going to look at root, it's not null, so now we can say root.add 10. And that'll do the recursive addition or marching down the tree or whatever we decide to do. Alright, let me see if there's anything else I want to go over from the assignment prompt. I think that's all I need from the prompt. Alright, questions so far? Alright, we got 15 minutes. Let's do a sample tree class. Let's put some specific code. Again, this will not be a decision tree because you get to write that. But let's just play with a tree class. All right. So let's make an empty tree. Let's add some stuff to it. And then let's do an in-order traversal, because we know what the order should be when we do left node right. It should be 1, 5, 10, 20, 78, which is definitely different from the order in which we're adding. So this is you know, just kind of a quick test of are we adding to our binary tree correctly. All right. So let's make a tree class. So we'll have a node called root, which will be the root of the tree. It will start its life null. And we'll make an add method. And there's an edge case here. If the root is null, then how do we go from a null tree to a tree containing a node with a value n? We create a new node, we make that the root. So node new equals, or let's just do root equals new node. And I'll set up a constructor for a node that takes an integer and makes that the data value. So I'll set root equal to new node, and I'll return. So otherwise the root already existed. So let's do our usual left-right check. So if the number we're adding is less than the data value of the root, we want to add to the left. Alright, now here's the trick. If the left child is null, we can't say, you know, root.left.add, because root.left could be null. So if root.left equals null, then there's nothing to the left. So we'll create a new node, we'll put the data value of n in that node, we'll set root left equal to that, and we'll return. Otherwise, root.left exists, so we'll call that node's add method to add n. Otherwise, we're going to add to the right. So, you know, if n's not smaller than the root data, there's no duplicates. Root is bigger than the root data, so we're going to add to the right. So if root.right equals null, root.right equals new node n, and return from there. Otherwise, root.right exists, so call that node's add method. And we're done. All right, so that should be a fine add method. I just put this in the wrong class though. Alright, so what's a node look like? It's got an integer data value, it's got a node called left, and it's got a node called right. Alright, so here's how we add to a node. If the number is less than the data value, see if there's a left child. If there is not, then set the left child equal to a new node. Otherwise, call the left child's add method. Otherwise, we're going to add to the right. If the right child is null, set it to a new node. Otherwise, call the right child's add method. So there's the add method that I wanted. So the add method in the tree looks like this. So if the root doesn't exist, make a new node. And return otherwise root.addn. Otherwise, just call the root node's add method. Alright, so there's an interplay here between the tree class and the root class. Yeah, go ahead.
New is misspelled. Not going to
Thank you.
fix that.
Alright, so at the tree level, we're actually defining the root of the tree as a variable in the class. The add method basically checks to see if the root is null. If the tree is empty, we just create a single node and we set the root equal to that. Otherwise, the root already exists. That's a node. We can call the add method in that node. And the add method does the usual, see if we should move to the left or the right. And if we should move to the left, just call the left node's add method. If we should move to the right, use the right node's add method. And the only caveat there is if the left child is null, we can't call its add method, right? But if the left child is null and we're supposed to insert to the left, just make a new node and set left equal to that. So this achieves the same end as our tree code in 222. But it's a different approach because of the way that we're structuring this, because we're trying to encapsulate the code for calling for performing these modifications in the same thing as the data that's being modified. So the last thing we need is the traversal method. So if the tree is empty, we'll just return. Otherwise, we'll call the print method on the root node. And then we're done. So we need a print method in our node class. And so how do we do this? If left is not equal to null, let's traverse the left subtree by calling its print method. And then we're going to print out the root node data. And then if the right child is not null, we'll call the right node's print method. And that's our whole recursive print algorithm. And then we're going to make a constructor. And our constructor takes an argument n, so it sets data equal to n. It sets left equal to right equal to null. And it returns from there. And I won't lay odds for our chances of this compiling. Okay, not bad. So let's run this, and there's the in-order traversal of our nodes, and they came out in order, amazingly. So there's the main program, right? Construct a tree, add using the add methods. This would be, you know, if you got the documentation for a tree class, it would say construct it like this, add with this, in-order traversal with this. And then under the hood, right, there's where the actual work is happening, is at the node level. And this very much mimics the algorithms we used in 222. But then there's also the tree class, which is what we actually interact with from the main program. And that's mostly just wrappers around calling methods on the root node, with the special handling of if the root node doesn't exist, we do something slightly different. So I'll push this code onto the server. This is not the PA3 tree class, right? But this is similar to it. And if you work through this, think about it, and then start making some changes to this, I think you'll be able to transform from here into, you know, the decision tree class that we want for PA3 without too much heartache. Different node structure, right? A string instead of an integer, some way of telling if the node is a question or an answer, but the rest of it's mostly going to be the same. We don't need to actually add with an add method, but we're going to have this ingest method, which is a separate thing. And then playing the game, as I said, you could put that as a method in the tree class if you want. That just starts from the root and moves down, asks questions, gets responses. All right. Kick that around in your heads. Bring questions. I've got office hours Thursday morning. We've got class Thursday. I've got office hours Friday. But Thursday, what I want to do is I want to start off by looking at Eclipse, and I want to go through how to download the specific version of Eclipse and Java that we're going to use for PAs 4 and 5. And you're welcome to play along. My suggestion is, you know, if you've already got Eclipse installed on your own machine, maybe you want to do this in a VirtualBox, right? And just start a completely clean Linux install in a virtual machine, and install on there, or try installing it alongside what you've already got, which I've done on my system and it seemed to work well. But you know, it's cleanest on a clean system.
Is there any? Are we going to be working with any like tool sets that are Linux specific, or?
So we're going to be using Eclipse with Swing and Window Builder, Java 11 and 2022-03 version of Eclipse, which I don't think is significant. Version 11 of Java is very significant. If you use a version later than that, it's not going to work on my tests. And we're definitely going to use Swing and Window Builder.
Okay. So I'll probably do this in a VM.
Yeah. All right, cool. We're at 10 after. I'm going to bid you farewell. Have a great afternoon, and I will see everybody next time. Thank you.
Thank you.
Have a great day.
Thanks, you too.
Thank you. Have a good day.
Thanks, you too.